Hi, it's me Kuber Luha, and in this video I'm going to demonstrate the voltage transfer characteristic of IC7400, which is a 2-input NAND gate. So here is the components required for this experiment. We need IC74001 IC, trim pot, breadboard, voltmeter and ADLM 1000 kit. So this one is the chip of IC74001, and there are four um, 2-input NAND gate, but we will use this one. So in this NAND gate, here pin 1 and 2 is for input and pin 3 is for output. Okay, so let's discuss about it. So here is the circuit diagram of this experiment. So here's plus 5 volt of VCC is connected with pin 1, and pin 2 is connected with trim pot, and trim pot itself connected with plus 5 volt and grounded. Okay, and the use of this first voltmeter is that to measure the input voltage of this pin 2, and the use of this voltmeter is the measuring the voltage of output voltage of pin 3. So and this use of this capacitor is basically filtering the noise, but in this case it is unnecessary. Now I have set this circuit as per the diagram, and you can see here's the for VCC, and this is IC 7400, and as per diagram I have set all these circuit components. Okay, now I have to do the checking connection of this circuit. So for checking continuity and connection, we will use this multimeter. So what we have to do, basically we have to do basically you can see here's the one just like volume like symbol. Okay, so we have to shift this one. Okay, it's already is there. And now checking continuity for VCC. Okay, so checking continuity for VCC, which is pin 14, basically pin 14 of IC7400, and it's all right, it's perfect. Okay, now moving forward to next one, checking continuity for trim pot. Okay, so let's do this one. It's also all right. Now checking checking continuity for this pin 1, basically, right, and it is also fine. So now checking for ground. So basically this is ground, and pin 7 is ground for IC7400. So wait a minute. Okay, it is also perfect. Now I am going to use ADLM 1000 kit. So I am using ADLM 1000 kit for supply 5 volt. Okay, 5 volt in VCC. So I am using this white for 5 volt and black for grounded. Okay, now let's connect this one. I am just connect this one in VCC side. Okay, and I have to use this ground in grounded. I have to do this grounded. Okay, now I have to measure the input which is pin second input, which is pin 2, and output. But when we changes in pin 2, what happened in output? Okay, now for checking value, I have to first grounded this black. Okay, now it is grounded. Now I have to put this one in pin 2, basically. Okay, basically okay, so this trim pot is now is very high. So let's decrease the value. So basically trim pot is adjustable octane resistance. So we can decrease moving with this screw in clockwise, and increase with moving in anti-clockwise. So let's decrease its value. Start with 0.2. Okay, so it's nearly 1.9 or 20. Okay, so now this is the input value of second input, the value of pin 2. Okay, now let's check output. So connect in pin 3, because pin 3 is output. Okay, now you can see, let's constant this one. It is 4.73 something, or 4. It should is 4.5 or 4 point something. Okay, so now let's increase value of trim pot. Okay, so increase value of trim pot, we need to rotate in anti-clockwise. Let's do in 0.4. Now let's take the value of output. It is once again similar with the previous time. Now we know that at a certain time, when we increase the value of pin 2, at a certain time output will be 0, and it NAND gate behave as a inverter. Okay, so let's increase value of trim pot until it is 0. This value is 0. Okay, and the input is that is 4.73, so 4.75. can see this is now 0. Okay, so basically all data are noted. Now let's discuss about it. After noted all data, we got this one. Whenever we increases the value of pin 2 from 0.2 to 0.4, 0.6, and likewise from 0.2 to from 0.2 to 2.2, value is value of output, which is value of pin 3, is 4.75 or something, which is constant value, right? And after that, when increase from 2.2 to 2.4, the value is slightly decreased. Okay, and after that from 2.6 to likewise, whenever we increases the value of trim pod, the value of p3, I mean pin 3, is 0, and this NAND gate behave as an inverter. Okay, so this was conclusion of our experiment. So thank you.